Hey guys, today we're going to talk about um, chapter 2.3 in the textbook, techniques for computing limits. So, to start out, let's start the example of the limit as x approaches 3 for the function f of x, where f of x equals 1/2 x minus 7. So, all we do here is, well, we know f of x is 1/2 x minus 7. So we plug in 3 in for x. So that's going to be 1/2 times 3 minus 7 equals the limit as x approaches 3, which is 3/2 minus 7, which winds up being 3/2 minus 14 over 2, which just equals negative 11 over 2. So that's the limit for that one. So now let's look at another example. Suppose now I have another one that says the limit as x approaches 2 for g of x, where g of x equals 6. Okay. So if I take the limit as x approaches 2 for g of x, which is equal to 6, well, it equals 6 because there's no x value for me to plug 2 into. So it's a constant function. So no matter what, it's always going to be 6. And the next example, I'm going to clear this really quick because this next one's going to definitely take some room, is we're going to use limit laws. So suppose I have functions such that it's the limit as x approaches 2 for f of x equals 4, the limit as x approaches 2 for g of x equals 5, and the limit as x approaches 2 for h of x equals 6. Now, the functions f of x, g of x, and h of x are just arbitrary functions. They could be anything. But the important note is that you notice how all the limits of these functions, right, that they all approach the same limit, and that is the limit as x approaches 2. So now, suppose I want to find the limit as x approaches 2 for f of x minus g of x over h of x. Well, I have to apply limit laws. So first off, the limit as x approaches 2 for f of x minus g of x over the limit as x approaches 2 for h of x equals, I'm going to move it down here. So that means it's just the limit as x approaches 2 for f of x minus the limit as x approaches 2 for g of x, all over, again, the limit as x approaches 2 for h of x. So the limit as x approaches 2 for f of x, well, we know from up here it's 4. And then minus, so what's the limit as x approaches 2 for g of x? It's 5. And lastly, the limit is x approaches 2 for h of x, 6. And let me just write the limit part. You always want to keep writing that in because that's what we're evaluating. So now, well, 4 minus 5 is -1, and that just stays 6. So therefore, the limit as x approaches 2 for these combinations of functions is just -1/6. And let's see, let me clear the board here. So another example is, suppose I have the limit as x approaches 2 for 3x squared minus 4x over 5x cubed minus 36. So for this one, well, I'm just going to plug in 2. Now, important thing to check here is, first off, be sure that your denominator doesn't come out to 0, because if it does, well, that means, it doesn't necessarily mean that it's undefined. And, meaning that it doesn't mean meaning that in this case, it doesn't mean, oh, that the limit doesn't exist. No, because sometimes you have to use other methods to go about trying to find that limit, algebraic methods and other type of methods, so on, which that will go into the next example. Anyway, you plug in 2 here, and really this is just simple algebra. You're just evaluating the function at 2. So 2 squared minus 4 times 2 over 5 times 2 to the third minus 36 equals the limit as x approaches 2. Well, 2 squared is 4 minus 4 times 2, that's going to be -8 over 5 times 2 to the third power is 8 minus 36 equals sorry about that, a slight disturbance. Equals let's see, 3 times 4 is 12 minus 8, and the denominator is going to be 40 minus 36. So then that gives me 12 minus 8 is 4. And 40 minus 36 is also 4. So therefore, it all just winds up equaling 1. So that's the limit as x approaches 2 for this rational function, is it just equals 1. And the last example we're going to go through is, now I have the function, now I'm taking the limit as x approaches 2 for the function x squared minus 6x plus 8, all divided by x squared minus 4. Now, remember what I said about the previous example. If you have a rational function, right, make sure you check the denominator, right? Because again, if you plug in the value and it's undefined, it does not, I repeat, it does not necessarily mean that the limit does not exist. I can't stress that enough. So if I plug in 2 into the denominator here, that's going to be 2 squared minus 4, which is just 4 minus 4, which is 0. So then you would have whatever x is, whatever the value of the top part is, at x equals 2 over 0. Well, that means we can't do it directly, but we can try to do something else. And what that would wind up being is, well, let's see if we can use some algebra to solve it. Well, let's see if we can factor it. So the AC method, 2 numbers that multiply to 8 and add up to -6. So what about -4, -2? Well, -4 times -2 is 8. -4 minus 2 is -6. So that works. So that winds up being x minus 4, x minus 2. And got to keep writing the limit part. Apologize for forgetting that. Over, well, factoring this is difference of squares, x minus 2, x plus 2. And look what happens. We have x minus 2 here and here, so x minus 2 cancels out both here and here. And that's going to equal the limit as x approaches 2 for x minus 4 over x plus 2. Well, now we can plug it in directly, because when I plug in 2 in the denominator, it's not going to be 0. So 2 minus 4 over 2 plus 2. And that's going to wind up giving me, well, 2 minus 4 is -2. So we have -2 over 2 plus 2, which is 4. So then -2 divided by 4, that's just -1/2. So the limit as x approaches 2 for this function is just -1/2. And that's going to do it for today. I hope this video helps. And see you guys next time. Have a good day. Bye-bye.